Welcome to Mickey's Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes. Coming to the problem statement, a square plate of 30 mm side rests on HP such that one of the diagonal is inclined at 30 degrees to HP and 45 degrees to VP. Draw the projections of the square lamina. So looking at the problem statement, we can just conclude that it is a square plate of 30 mm side. So the polygon given to us here is a square measuring 30 mm, and it is resting on HP such that one of the diagonals is inclined at 30 degrees to the HP and also 45 degrees to the VP. We need to draw the projections of the square lamina. So first let us try to understand the problem statement here. So it is not the resting condition of the edge, it is the resting condition of the corner. Only when it is resting on one of its corner, we can get a diagonal which is to be inclined to both HP and VP. So whenever we consider a diagonal, the diagonal will be having one of its true length in the initial position, but when it is inclined to HP, obviously it is going to have the apparent length, or the true length of the diagonal is going to change in the second position. So we can just conclude that this is a beta angle problem. And also the word appears to be inclined to VP at 45 degrees is not given to us. The given angle here is phi and not the value of beta. So with these conclusions, we can arrive at the solution for the problem statement by following the steps. So first, let us draw the xy line of any arbitrary length and label this line as x and y, and also the reference planes as VP and HP, vertical plane and horizontal plane. So now let us try to draw the square in the top view. So initially let me draw the square resting on one of its edges, that is 30 mm, 30 mm. So now let me select the entire square and rotate this entity in such a way that it is resting on one of its corners. So let me select the two extreme corners of the diagonal of the square and ensure it is rotated at a position of 90 degrees like this. So you can just see that it is resting on one of its corner. So now let me annotate this square as ABCD. So by drawing the projection lines, we will get the front view. So before we draw the front view of the square, let us annotate this square lamina as ABCD. This is corner A, it is resting on the corner A. This is corner C, and this is corner D. So the diagonal for our reference is A to C. So we'll just consider that the diagonal is AC. Okay, so this diagonal AC is inclined to the HP at an angle of 30 degrees and also to the VP at an angle of 45 degrees. So now let us draw the projections of this square lamina and get the front view. So you can just see that AC is the diagonal. So before we do this, let us just trim this portion of the XY line and draw the front view of the square lamina using the thick line. So end point of this to the end point of this and then to the end point of this. So if you're making it a continuous line, you will not be getting this point, that is B and D. So you have to ensure that it is a broken line. So this is first part and this is the second part. So now we will annotate this. So this corner is visible, so it is A dash, and here for the observer B dash is visible, D dash is not visible, so it is inside the bracket, and here it is C dash. So this is the annotation of the front view of the square lamina. Okay, so now he tells that this particular diagonal, that is AC, is inclined to HP at an angle of 30 degrees. So now what we will do is we will select this front view of the square lamina along with the annotations. and rotate it at an angle of 30 degrees to the HP. So before we rotate, let us move this, ensure the copy is on. So keeping this B dash D dash as the point, I'll just move it to the right hand side of the XY line. And now let me select the rotate option. Okay, so the corner A, so I have to place it in such a way that the corner C will be upwards. So first point of rotation, second point of rotation. So the angle is 30 degrees. So it is asking the direction either in the HP or VP, but the inclination is with respect to the HP, so it has to be in the VP like this. So now we can just measure the angle, which is equal to 30 degrees. And now let us draw the projectors downwards. So select a projection line of thickness 0.13 mm and draw the projections from all the corners. So if it was a continuous line, we would not get this point. So that is the reason why we should make it as a discontinuous line. So now we will draw the projectors from D. So it has to intersect here, and projector from C and A. So it has to reach here, and also the projector from B has to meet the projection of B, and then we will complete the top view of the square lamina. Ensure it is a continuous line of thickness 0.50 mm. First, second, third, fourth, and fifth. So this completes the square lamina. So now let us just trim the unnecessary projection lines. So this is not required, it is not required, this line is not required, and this line is not required. So this is the projection of the square lamina in its second position whenever it is inclined to the HP at an angle of 30 degrees. Now the important point for us to observe here is, let us just try to measure the length of this diagonal here. In the initial position it is 42.43, but whereas when the square lamina is inclined to the HP at an angle of 30 degrees, you can just see that in the top view the diagonal is measuring 36.74. So this is what is the distorted position of the square lamina. So keeping this in mind, we can just see that it is this diagonal which is also inclined to VP. So obviously the given angle here is a non-beta angle. So here it is the angle phi which is given to us, and we need to construct the beta angle. So for that, let us follow the procedure. Select a continuous line of thickness 0.13 and draw a line of any arbitrary length, and from any arbitrary point, first let us draw the diagonal AC measuring 42.43 mm at the given angle of 45 degrees. So here it is minus 45. So this is the first step, and then we need to draw the locus line from the end point. So we will draw the locus line passing through the end point. Okay, so for better understanding, let us first annotate this. So this is D, and this is A, and this is B, and this is C. Okay, so now here also this point is C and this point is A from the first position. So for better understanding, let me just call this as A1. Okay, so now what I'll do is, after having drawn the projection line on the locus of A, so let me annotate this line as locus of A. So this is the locus of the corner A. So now on this locus line, we need to select the tangent, okay, arc by center point, and then cut an arc measuring 36.74, keeping C as the center. So now, keeping C as the center, ensure it is a continuous line and try to cut an arc of length 36.74. So select this arc length and enter the length as 36.74, and now let us cut an arc such that it is intersecting the locus of A. So now using the line option from C, let us try to intersect with the point of intersection of the locus line and the arc. So this is the, see, this is 36.74 and this is 42.43. So now let us measure the angles. So this is the beta angle, which is equal to 55 degrees, and this is 45 degrees, which is the angle given to us. So that is the value of 5, and this line is CA1. So to have a better clarity, let me just change the color of this particular line. So this red line is the CA1 line, and this CA is the initial length of the diagonal, and this is the apparent length of the diagonal. So using the initial length or the true length and the apparent length, we are going to construct the beta angle, and the beta angle is 55 degrees. So now we will draw a line of arbitrary length, but the value should be, the angle value should be 55. So here it is minus 180 plus 55, so that this angle will be 55. So let us measure this angle. So this is 55. Okay, so now on this 55-degree line, we are going to place this distorted position of the square and then get its front view. So for that, let us select the square along with the annotations, and now we will select the move option, ensure the copy is on. So let me select the point A. Okay, so I didn't get the diagonal here. So what I'll do is, for time being, let me just trim this projection line, and delete this dimension also. So now I can have this diagonal. So along with the diagonal, let me select the square and also the annotations. Now select the move option, ensure the copy is on. So keeping the point A1 as the reference, move it on the 55-degree line, and then select the rotate option. First point of rotation, second point of rotation, tilt until it is going to be overlapping on this XY line. So just show the angle between. So it is 55 degrees. So now you can just extend this projection lines and then show the dimension of the diagonal in the initial position, and also show the dimension of the one side of the square, which is 30 mm. Okay, so now draw the projections in the front view, and then draw the projections from the top view to intersect this. So the corner D is here, so it has to intersect here. Corner A or A1 is here, and then B is to be here, and the point C is here. So now we will draw the front view of the square using the thick lines. So it is A, it is resting on one of its corner A, and then from A to B. So A to B and A to D is also there. So A to D, so the end point of this line, then D to C, then C to B, and then from B to A. So ensure that it is all the point of intersection of these lines. Use the trim option and trim the unnecessary projection lines, and then annotate the front view of the square plane. So this is C dash, and this is D dash, and this corner is B dash, and this corner is A dash. So to verify, here on the right hand side of the observer, it is resting on one of its corner A in the initial position. Even in the final position, here it is resting on one of its corner A dash. So with this, we have completed the problem. So before we end up, we will just show the directions of the projection line using the leader option. So the direction here is upwards. Here it is down, and then from left to right, upwards, and here it is from left to right. So this completes the solution for the given problem statement, which states that there is a square lamina of side 30 mm resting on one of its corner, and then the diagonal is inclined to the HP at an angle of 30 degrees, and also the diagonal is inclined to VP at an angle of 45 degrees. But we do understand that with respect to the vertical plane, we are going to consider this diagonal which has changed its length from its initial position, and therefore we need to construct the beta angle for the inclination with respect to the vertical plane. And this is the method to construct the beta angle, that is taking the diagonal length of the first position, and then given angle phi, draw this line, draw the locus, and then measure the length of this diagonal in the second position, and then cut an arc, and then try to intersect that point of intersection of the locus line and the arc to the origin point, that is the other corner C, and that angle is the beta angle. So use that beta angle to place the square on one of its diagonal, so that the third position is complete. So this completes the problem statement. Thank you all for watching.